NASA scientists just found a mysterious gap in the universe that makes zero sense. Did you know that there's an area of space that makes literally no sense? It's true. In fact, it's such an anomaly that NASA scientists have just discovered it, and they're totally confused by its existence. Welcome to the Space Invaders, your home for all things space and cosmology. Whether you're a casual viewer or a hardcore enthusiast, we've got something for you. We'll be talking about everything from the latest discoveries in exoplanet research to the most recent news about NASA's missions to Mars. In 1923, Edwin Hubble showed that the universe was far larger than expected by discovering that what we thought were swirls of gas on the edge of our own galaxy were actually galaxies in their own right, lonely island universes we could spot across an empty sea of black. That led to a comforting thought: we now know that even the darkest patch of sky, when seen through the telescope named after Hubble, is dotted with clumps of luminous stuff like our Milky Way. But there's another view of the universe, like the horror cliché of flipping an image to its photonegative. Since 1981, when astronomers found a vacant expanse called the Boötes void, we've also known that the universe has holes of cold, dark, lonely nothing that are larger than anyone expected. To truly understand the universe, we may have to gaze into the abyss. The Boötes void, which you will assuredly not see if you look at Boötes, the Plowman constellation adjacent to the Big Dipper, is a rough sphere about 280 million light-years in diameter. Galaxy-wise, it's a ghost town. When we first saw the void, we found only one galaxy inside. Since then, we've detected only a few dozen more. By contrast, the Virgo supercluster, a smaller region that includes the Milky Way, contains over 2,000 galaxies. Andromeda is one of the most prominent galaxies in the local vicinity, and it is visible to humans despite the fact that we are inhabitants of the Milky Way. Because Andromeda was so close, Edwin Hubble was able to examine each of its stars, which ultimately led to the discovery of the universe's whole extent. If our galaxy were located in the Boötes emptiness, our nearest neighbors would be located a great distance away, giving us the illusion that we are at the center of the universe for a considerably longer period of time. This is not a result of random statistical fluctuations. At extremely vast dimensions, the cosmos is sometimes compared to a cosmic web, in which invisible filaments of dark matter are thought to support the bright structure of the universe. To further understand this concept, it may be helpful to think of it as cosmic foam, similar to the soap bubbles that form in a bathtub. Galaxy clusters tend to congregate in the walls, filaments, and intersections of structures, just like suds like to congregate where bubbles connect. The space in between is generally empty. The issue was that the Boötes void was merely an excessively large space. The dense borders of voids exert a gravitational force that is far stronger than the pull exerted by anything in the void center. However, the cosmos was not yet old enough to have had sufficient time to blow up such a massive bubble. For an answer, we had to wait until the discovery of dark energy in 1998, which is a type of cosmic pressure that causes empty regions of space to expand as if someone were simultaneously pushing air into all of the soap bubbles in the universe. The current surge in the cataloging and mapping of voids has led many astronomers to the conclusion that these eerie places, which reveal the underlying structure of the cosmos, may hold the key to the next significant discovery. Soon, statistical assessments of their forms may be able to let us measure dark energy, gravity, and any other unknown new forces more accurately than we ever have before. And in the process, they may teach us how to become comfortable with the void that we are experiencing. If galaxies are cities, then the edges of a void are the suburbs, and the center is the deepest wilderness. But an atlas isn't complete if it includes only cities and roads, it also needs empty spaces in between. Scientists are increasingly entering the deep, dark wilderness of the void to complete their atlas, and in doing so are learning about other, greater dark presences in our universe. Dark matter, for example, makes up 80% of the matter in our universe, but neither emits nor absorbs light. Because its gravitational force gathers together atoms to make galaxies and clusters of galaxies, though, the stars, gas, and dust that constitute the visible stuff of the cosmos reflect the underlying dark matter distribution. Where galaxies are thickest, dark matter is densest. The reverse is also true: in a region empty of galaxies, dark matter should be sparse. Since the discovery of the Boötes void, astronomers have found a number of similar empty patches using similar methods. There's even one near the Milky Way, creatively named the local void. Voids are ubiquitous and come in a range of sizes and shapes. But it's not enough to know voids exist. Scientists want to know how many there are, how large they are, and how they are distributed in space and time. To accomplish this, scientists are turning to gravity. All forms of matter and energy exert a gravitational force, which in turn affects the path of light, as predicted by Einstein's general theory of relativity. Are we living in a giant cosmic void? A team of researchers says the Milky Way resides in one of the observable universe's darkest regions, but some experts aren't so sure. Don't panic. Cosmic voids are actually all around us. According to researchers at the University of Wisconsin-Madison, our very own Milky Way galaxy may float near the center of one of these voids. Using data from large-scale telescope surveys that count galaxies, the researchers concluded that the Milky Way exists near the center of a region that has fewer galaxies than other parts of the universe. They estimated the size of this void to have a radius of about 1 billion light-years. If they're right, humans are living in the middle of the largest known void in the observable universe. These findings were presented at a conference of the American Astronomical Society in Austin, and they show that the researchers have taken this concept one step further since they initially presented it in 2013. According to what they indicated, the location of the Milky Way within a vacuum would assist in explaining an issue about the methodology that astronomers use to determine the rate at which the universe is expanding. After the Big Bang, which occurred more than 13 billion years ago, the universe has been expanding ever since, and there is evidence to suggest that the rate at which it is expanding is speeding up. On the other hand, there is some debate over the exact pace of expansion. Some astronomers watch bright things in the area of the local cosmos, such as Cepheid stars or supernovae, and analyze the light from these objects to calculate how quickly they are receding from the Earth. Others take a more in-depth look into the history of the universe by researching the cosmic microwave background, which is the radiation that was left over from the Big Bang and continues to fill the cosmos now. The measurements obtained from the local universe turn out to be greater than the ones gained from the early universe. This difference might be attributed to the fact that various measurements produced different outcomes. Astronomers are unsure as to whether the inconsistencies are the product of random fluctuations or whether they represent signs of new physics that we do not yet comprehend. Outro. Thanks for watching. If you liked this video and want to see more, please like, share, and subscribe. If you have any questions or suggestions for future videos, please leave them in the comments below. Thanks again, and I'll see you next time.